first things first, this equation that you were trying to solve is, pay attention to that symbol. It is not multiplying or dividing. It is subtracting. Okay? Think of it like actual decimals. 1.5 times 10 to the 9th power minus 2.84 times 10 to the 8th power, resulting in scientific notation. These two do not match. Therefore, our decimal places do not match. They look like they match, but they do not. Let me show you what I mean. If I were to do 1.45 times 10 to the 9th power, I'm going to move that over 9 times. So 1.45 and I'm going to go ahead and move it over 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Filling in all my zeros. Now, if I were to match up my decimals right now and go ahead and subtract that, 2.84, and this time I'm moving it over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Fill in my zeros. You can see my digits no longer line up, which is incredibly important when you are adding and subtracting. You could go ahead and align those if you would like to, and making sure that this stays on bottom, you would technically have 2, 8, 4, 0, 0, 0, 0, 0, and 0, and you'd subtract it. It's a lot of digits to keep track of, though. It would work, but it's a lot of digits to keep track of, whereas with scientific notation, I can make my life easier. Or you can just use scientific notation, keep it simple, so you don't have to deal with all those zeros and accidentally mess up, which is why scientific notation exists. So you have 1 4500ths times 10 to the 9th power minus 2 8400ths times 10 to the 8th power. We just need to make sure that before we subtract these, just like you would over here when I'm adding all the zeros on, that these two exponents match. Okay, how can I do that? Well, I can either add 1 on this, and because I would be adding 1 on this, I want this to get smaller. Then when I multiply it by 10, 9 times, that decimal doesn't go over too many times, so I would move the decimal over here. Or I could move this decimal over here, making my original number bigger and my exponent smaller. Doesn't matter which one. I'm going to go ahead and do 10.5, not 10. Let's see here. So 14.5 times 10 to the, so I moved it over, making my number larger. Don't have to multiply it as many times, so I'm going to go to the 8th. I went down because I don't have to multiply as many times now. I took 1 place value out in order to make my number line up. Since I did that to my first scientific notation, I don't have to touch my second one. So now I just line up my decimals. 2.84 times 10 to the 8th power. Now I can just subtract it like regular. Keep on my times 10 to the 8th power. That's where all those zeros come into play. 0 minus 4, can't do that, borrow. 10 minus 4 is 6. 14 minus 8 is 6. 3 minus 2 is 1, and 1. So we have 11.66 times 10 to the 8th power. Technically, we can only have one digit in front of the decimal, so we would want to move our decimal place back over 1, which means our exponent's going to go up by 1 since we're getting smaller. So we have 1.166 times 10 to the 8th power.